Have you ever wondered when image generators, particularly text to image generators, generate excellent images? Okay. Have you ever wondered how they basically generate them? Have you ever thought what is the algorithm behind it? In today's video, we will go ahead and understand how a very popular image generation model called GAN model works. And what is the interesting game its components play with each other to give you such a realistic looking and real looking images created from a latent space. Now let's come to the question. Here a banana is thinking with its brain. In reality, banana does not have any brain. Okay. But when I asked or prompted a LLM to tell me banana thinking about itself, how to generate an image, you could see that the image depicted is almost true to the feelings or my prompt. Okay, so now, how is this generated? Okay, so this generation happens due to a very good game. Okay, out of many algorithms that can generate images, today's topic is GAN model or GAN method of generating images. We will see what is the game around. So GAN is Generative Adverserial Networks in English. And if you see, this typically plays a similar games like we used to play in the childhood. If you remember in India, there used to be a game where four people or four children used to sit, and in one of the chit there used to be Ram, and another chit is like Sita, and the others have a different rules around in the same chits, various things, and you randomly pick up a number, and Sita has to play the bluff game. The guy who has got the Ram chit has to guess who exactly Sita is. Okay, so now Sita used to fake their identity. Okay, so now if the guy who is holding the Ram's chit guesses correctly, he will get the points. If the guy who is able to fake his expressions or methodology to hide that he has got the Sita chit, then he will get the points. Exactly, this is how a two components within GAN model, which are called as generator and discriminators, play with themselves to give us exceptional quality images. Let us see what is that algorithm, what are the components of them. As you see in this particular image, generator has got a latent space and random noise with it. Okay, so it doesn't know it in practice doesn't know which one is the real image and which one is the fake image. Okay, so now what it does is it continues to generate the random images which are obviously fake. Okay, by the network it has got. Okay, then it passes to the discriminator network. Now the discriminator network is having a real data. Okay, so now since the discriminator has a real data, it can tell whether the generator generated image is a real one or a fake one. It only says whether the generated random image is fake or not. Now, every time the generated image is identified by the discriminator as a successful fake, generator gets trained again or it gets the feedback. Otherwise, discriminator gets feedback that look, you are not able to figure out a fake image. You have passed a fake image as a original image. Now, this is a race that goes between generator and a discriminator. Both the networks get better and better and better and better over the time. Okay, so that is how a GAN model is giving you excellent images out. Now you may question me how this is going to give you excellent images. Okay. So let us see how it is going to give the excellent images too. Let us take a example here. Okay. Let us suppose your generator is given a task to generate fake currency. Okay. Now discriminator obviously has a real currency samples and it knows. Now generator will start generating, some kind of a fake. Now discriminator says no. Generator presents one more fake. Discriminator shows no. And slowly generator converges towards a good image where it passes through the discriminator. So that's how the generator network, which is essentially a convolution network, will understand how to generate specific texts and their combinatories. That is how, over a period of time, all your image generation models have become very, very good, very precise, very fast, because they have built in network of what is true, what is false, and what will pass through the discriminator. So now discriminators also have got better and better in terms of the photographic composition and the components, what to add, what not to add. When you are adding, whether the composition is good or not, will it suit or not, all these things have happened because of this continuous learning from each other. Okay. And that is the very reason why GAN networks have been the fastest networks when it compared to stable diffusion or diffusion models or other models, other types of image generation models. And majority of the hosted LLMs are using generation or GAN generators for their videos and also the still images. Okay. So that is how GAN networks actually work under the hood. Okay. Let us go ahead and understand one more example of taking this as an artist. So now what you can see, this entire thing is, instead of fake currency provider and fake currency generator, you can also assume them it to be a art character and artist or a budding artist. Every time a budding artist generates a art that is not in in alignment with the expectation by the art character or human, the generator learns. Every time human puts a up, positive side, thumb up, discriminator learns on the better. So that is how, over a period of time, when lots and lots of people actually put these questions and train these questions, your image generation algorithms have become so good. So that's how you are able to see such a excellent image generations that are happening today. Okay. So you see, I am showing you some samples here. All these image generation samples, whatever are happening, are because of the continuous discriminator training with a hundreds and hundreds of real images to depict something very, very near to the original. So now when things are getting generated, when the things are typically getting generated, you can also see these things also, the generation also gets happen better and better and better. So that's how your image generation models are today able to generate excellent, high quality, good composition images. Now the question is, are the GAN networks only networks that can generate the images? Obviously, no. There are many methods and many models that will generate the images. We will learn about the other methods, the second popular and most artistic models, which is diffusion and stable diffusion, in coming days. And we also will learn about how to put the prompts and their compositions, prompt compositions, this weekend. So this weekend, Don't miss the image generation prompting techniques video by Medhoentra. So, as usual, Medhoentra is trying to bring artificial intelligence very much simplified in the simplified terms to understand and remember without a lot of mathematics around, because our concept is to put the concepts in place. So do follow Medhoentra, and if you like our content, please suggest Medhoentra to your friends also. Thank you. Thank you guys.